Today we are going to talk about adding and subtracting fractions and mixed numbers. Okay, so to start, the very first thing that you want to do is to make sure that you have two fractions. We want to make sure that we are not adding and subtracting mixed numbers. So if we have mixed numbers like we do here, we do convert them to improper fractions before we move on. After that, we find the LCD or the LCM of the denominators. We want the lowest common denominator, which in this case is 20, so that we can then get both fractions to have the same denominator, allowing us to add and subtract. If we do not have the same denominator, we cannot add and subtract. From there, we go ahead and make sure that we are finding the equivalent fraction. So down here, I multiplied 4 by 5 to get 20. To make sure that my fraction is equivalent, I multiply my 19 by 5 as well. So whatever I do to the bottom, the denominator, I need to do to the numerator as well. So 4 times 5 is 20, and 19 times 5 is 95. Then I do that for my second fraction as well. Here, to get from 10 to 20, I multiply by 2. So then I also multiply my numerator by 2 as well. So now I have two new fractions. These fractions are equivalent to my originals, but they have the same denominator. So now I can subtract. When I subtract and add fractions, I keep my denominator the same, but I change my numerator. So I just subtract 95 minus 46, getting me 49. Then from there, we can write our answer as a improper fraction, which would be 49 over 20, or we can convert it back to a mixed number, which would be 2 and 9/20. So let's give a couple problems a try. Let's try this one first. 3/4 minus 1/3. From here, my first step is going to be to find the LCD or the LCM. So I make my list of multiples for 3, 3, 6, 9, 12, 15, and then 4, 4, 8, 12, and we have a match already. From there, I'm going to rewrite my fraction, my problem, 3/4 minus 1/3. But now I find those equivalent fractions. So I want my same denominator to be 12. Now, to get from 4 to 12, I multiply by 3. Because I multiply my denominator by 3, I will multiply my numerator by 3. 3 times 3 is 9. Over here, I multiply my denominator 3 to get 12 by 4. Because I do that on the bottom, I do that on the top as well. 1 times 4 is 4. From here, I go ahead and I've got two new fractions. 9/12 is equivalent, has the same value as 3/4, and 4/12 has the same value, is equivalent to 1/3. 9/12 minus 4/12. My denominator stays the same. 9 minus 4 is 5. Therefore, the difference between these two fractions is 5/12. Let's try another problem. This one's adding. Here I've got 6/7 plus 1/2. What is the LCM or the LCD of these two fractions? Well, I go ahead and I write out my multiples. Okay, 14 they have in common. So over here, I've got my two fractions, and I want their denominators to be 12. 7 times 2. Ooh, excuse me, I want it to be 14. I wrote 14, said 12. 7 times 2 is 14. Therefore, up here, 6 times 2 is 12. And then on the second fraction, I multiply by 7, getting me 7/14. From here, I've got those two new fractions. 12 fourteenths plus 7 fourteenths, getting me 19 fourteenths. From here, this is my sum of those two fractions, and I can rewrite that as 1 and 5 fourteenths as a mixed number. It just sort of depends on what the question's asking you. All right. So let's go ahead and try a couple of mixed number examples. Let's start with 2 and 1/6 plus 3 and 4/9. So like I said before, we do not want to add or subtract those mixed numbers. We are going to convert them into improper fractions. So we've got 2 times 6 is 12 plus 1 is 13 sixths. And then we've got 9 times 3, which is 27, plus 4 is 31 ninths. Okay, so we go ahead and we find our LCD. 6, 12, 18, 24, 30, 9, 18. We've got to match pretty quickly. So now I go ahead and take my fractions, not going back to our mixed numbers, going back to our fractions. And we want that denominator of 18. To get from 6 to 18, I multiply by 3. Therefore, up top, I also multiply by 3. 13 times 3 is 39. Over here, 9 times 2 will get me to that common denominator of 18. So I multiply 31 by 2 as well. 31 times 2 is 62. So now I've got those two equivalent fractions. Okay, 39 eighteenths is equivalent to 13 sixths. I add that to 31 ninths equivalent of 62 eighteenths. From here, I keep that denominator the same. My denominator always will stay the same here. My parts don't change. My total parts don't change, which is that denominator. So I just combine the numerator. 39 plus 62 will get me 101. Now I can rewrite that as a mixed number. 18 goes into 101 5 times. That gets us to 90. So we have 11 left over. And our 18 again stays the same. So your sum here is 101 eighteenths or 5 and 11 eighteenths. Let's do one more together. We've got 3 and 2/3 minus 2 and 4/11. Again, I need to figure out what my equivalent expression is going to be while these are turned into improper fractions. 3 times 3 is 9 plus 2 is 11/3 minus 2 times 11, which is 22, plus 4 is 26/11. I've got my denominators of 3 and 11. What is my common denominator? Well, if I count by my 3, that's going to get me all the way. I know that my multiples of 11 just keep on, 27, 30, 33. 11, 22, 33. 33 is my match here. Okay, so now I've got that converted fraction. I've got my improper fractions. 26 minus 11. I want my common denominator to be 33. To get from 3 to 33, I multiply by 3. By 11. 11 times 11 is 121. I was thinking over here. 11 times 3 is 33. 26 times 3 is going to get me 78. So from here, again, I've got my new equivalent fractions that will allow me to subtract. 121 33rds minus 78 33rds. Again, my denominators stay the same. And then I take that difference between my two numerators, which is 43. I can rewrite that. 33 goes into 43 one time with 10 left over, and the denominator stays the same.